In this video, we are going to learn about xt graph. Xt means position and time graph. That position can be measured in distance or can be measured in displacement with a time. So what is an xt graph? A graph which shows the different position of an object from origin at a different instant. The basic point is here, the object from origin. So whatever the distance or displacement you are to measure at a different system, it should be measured from the origin. In this video, it is the time axis and it is the position axis. So at time t1, when your watch shows a time of t1, its displacement from origin, suppose that this is the origin, and at t1 the position is x1 that is marked on the graph, and these two coincide at this point, so this point is taken. At time t2 the position of the object is x2, that is again the position should be measured from the origin. So at time t the total distance is x2, this distance is x2 at time t2. So this point is the coinciding point for these two is here, this point. And similarly the x3 is the position from the origin at the instant time t3. Position always measured from the origin and time that you noted down. So one step by step at a different instant you have different position, and when we draw this on a graph paper we get this kind of graph. This graph is called xt graph. For example, an object at time t1 that is at 1 second, the position from the origin was measured 3 meter. Suppose that it was 3 meter. So at time 1 second the position is 3 meter. At time 2 second, after 2 seconds of the start, the position of the object from the origin is 7 meter. So 7 meter is taken. So at the graph for this point is this one, and at the end of the 3rd second the position from the origin is 9 meter. Always you measure the position from the origin. So at time 3 second the position is 9 meter. Similar way, up to 5 second I have noted all the points, and when we join these points with line we get a graph, and this is an xt graph. Different kind of xt graph we can learn by. Let us see what is the importance of xt graph. Using xt graph you will be able to find out the position of an object at different instant, and you can have another importance of this graph. Just first let us discuss what we can get from it. Slope of the graph between a and b. So in this graph the point a and b are here. What is the slope? Slope हिंदी में इसको ढलान कहते हैं. So what is the slope? So then to find the slope of the graph between a and b, we have to take this divided by this. So what will be this much? X2 minus x1, and this one is t2 minus t1. Actually t2 minus t1, that length is t2 minus t1, and this length is x2 minus x1. So slope of the line AB between the point AB is x2 minus x1 divided by t2 minus t1. So there is a change in position divided by change in time. So you know that change in position divided by change in time, that gives the speed or velocity of the object. Similarly, we can determine the slope of the line between C and D. So the slope of the graph between C and D can be determined using the this length divided by this length, height divided by base, and this height is x4 minus x3 and this length is t4 minus t3. So again the slope of the line CD is x4 minus x3 divided by t4 minus t3, and this shows the changing position and this shows the changing time. So ratio of the position change divided by time, that gives the speed and velocity. So what we come to know from this graph, we can find the average speed or average velocity between two given point in the graph. Student, we have an xt graph, and how can we discuss what are the what this graph shows to us? What can we calculate from this graph? We can easily find out. Now in this xt graph you saw different portion of the graph. Here A to B, what is the velocity and how the object moves? Actually you can see as the time increases, the object position changes continuously, and the slope, you can check the slope at every point. The slope is same, so the object is covering the same distance in same interval of time. That means equal distances in equal interval of time. It means the distance covered per second is constant. The speed of the object in this region is constant. It is moving away from the origin. The object is started from a point. As the time passes, the position changes, but with constant slope. And you know that slope shows the speed or velocity of that object, and the slope are same, therefore the speed and the velocity are the same, that is uniform. Now in this second section, the part B, you can see the time passes, the position of the object hasn't changed. It is already at this position. The position is not going to change with time. In this region, that means the object at B has stopped and it is not moving more. From C to D, what we can calculate? If you can draw the slope at these points, at this point you can find the slopes increases. And what slope shows here? The slope shows the velocity or speed of the object. Here the slope is less and it goes on increasing continuously with a constant value. Therefore here the velocity increases constantly. So in this region the object is accelerated. In the next part or the last part of the graph D to E, what it shows, just draw 2 or 3 slopes on this graph. What we find, the slope was initially steeper, but the slope goes on decreases continuously. It means the velocity in x graph, the slope shows velocity. So velocity just after D was larger, it was greater, but later on the slope decreases, that means velocity decreases. So here the object is deaccelerated or it is retarded. Velocity is going to decrease continuously. And overall, if you can see, the object is non-uniform. Somewhere the object was at constant speed, somewhere the object was stationary, somewhere the object was accelerating constantly, somewhere the acceleration was. So total motion in the xt graph is non-uniform motion. Now Vt graph, V may be velocity or the speed. So whatever you are choosing, that depends on you. If it is velocity, then it is called velocity time graph. It is speed, then it is called speed time graph. So a Vt time graph is a graph which shows the velocity or speed of an object at different instants. Suppose that an object travels on this line at the instant t equal to 0. At the instant t equal to 1, the object is here, and the object is here at t equal to 2 and t equal to 3. And you are told to record the velocity. Suppose that at this instant the object had a velocity v1, then at this point v2, and as velocity or speed at that point v3, and here v4. So drawing this t and v on a graph, that gives a velocity time graph. As an example, I have taken here the time, different time or different instant you have recorded the velocities, At the time when your time starts, that is at the starting point, velocity is 2 meter per second. So when time is 0, the velocity is 2 meter per second. When time is 1 second, then its velocity is 4 meter per second, and the point is this. When the time is 2 seconds, the velocity at that instant is 5 meter per second. So I have given this point. And at the instant t equal to 3 seconds, the velocity recorded by you was 8 meter per second. So the point will be this one, and when we combine this with lines, this gives a velocity time graph. Let us see what are the importance or significance of VT time graph. Actually, using VT time graph, you will be able to find the velocity or speed of the object at different instant. But the most significant things that you can derive from the graph is, just check it. Suppose that in this graph I have to find the slope, dhalan, of this graph from C to D, what it gives. So slope can be obtained of this line CD by dividing this height with the base. So this height, total height is V3 and this height is V2. So total height is V3 minus V2, and the base, that is the total length T3, and this length is T2. So T3 minus T2, that gives this length. So V3 minus V2 divided by T3 minus T2. What is this? This is the change in velocity between these 2 points C and D. This is the change in velocity between these 2 points C and D. And the denominator T3 minus T2, that is the time change during C to D. So slope of CD, that is change in velocity divided by change in time, and it is called rate of change of velocity. And rate of change of velocity, that gives acceleration. So in a VT time graph, the slope of the graph at any instant or any between any 2 points gives the acceleration between these 2 points of that object. Second importance, what we can have from the area of that VT graph. I have taken a simple VT time graph axis in which velocity doesn't change, and at instant t, up to instant t, the velocity remains t. And if I want to calculate this area, this is the VT graph, and area with the time axis, what it gives. So area of VT graphs with time axis, this is equal to length into breadth. So length into breadth, that is velocity into time. What you get, the velocity into time, it may be distance. If it is a speed into time, then it gives distance, and if it is velocity, and it is time, then it gives displacement. So area of VT curve with time axis, that gives the displacement or distance covered by the object during that interval. Let us describe a VT graph. How we can describe a VT graph? So I have solved a VT graph at different instant. The motion of the object are different. In the region A to B, you can see the time has changed, but the velocity, value of velocity hasn't changed. So it is a uniform motion, and the velocity remain constant throughout A to B. Now in the portion B to C, just draw, you can see that here there is a slope. But the slope at every point is same, the constant. So slope in a VT graph gives the acceleration. So here the object is accelerated, the velocity goes on increasing. The velocity has increased from u to some value, suppose that v. So and the increase or the change in velocity is constant. So acceleration is there, and the object constantly accelerating with a constant value. In the region C to D, if we can draw 2 or 3 slopes, you can see the slope is increasing, and in a VT graph, slope shows the acceleration. So the slope is increasing, that means acceleration is increasing. The motion, the velocity of the object increases by different amount at different instant. So acceleration is not uniform here. Similarly, in this case, the velocity goes on decreasing, but the acceleration also not constant. Acceleration is also not constant. initially the velocity decrease is less, but later on the velocity decrease increases. So rapidly the velocity decreases. In this region, again the velocity decrease is more, but the slope goes on decreasing, velocity decreases less. And finally, if I can draw a line, straight line E to F to G, here the velocity finally becomes 0. The velocity of the object becomes 0, and in this region from F to G the velocity decrease is uniform and finally come to rest.